Hello. Hi guys, good morning. Welcome back to a new video. And first of all, the video is late because in this problem, I was stuck at a point for around more than 1 hour. I could not figure out what the error I was getting. And I'll show you that where I was stuck. And actually, there's a high chance that you will be also not able to figure out, okay, why this extra thing should happen or would be happening. Let's start off, and again we'll see every approach from recursion, which means simple brute force, recursion, memoization, bottom up optimized, bottom up optimized plus. So yeah, let's be ready. Let's rock on. It has been asked by Rippling, Amazon, Rippling, Apple and Google. So let's start off. It says that inverse pairs array, and I'll also show you all the similar kind of problems which can be used or which is actually similar to this problem, or inside this problem if something is useful, that also I'll show you. Let's see. This will be very much helpful for you, considering that. Okay, I'll show you. For an integer array nums, an inverse pair is a pair I comma j, where like the indexes, which means I is less than j, and nums of I is more than nums of j. So it's called as an inverse pair, which means if I write elements in this sequence, so if my element which is at the lesser index, it is more than the element which is further to him, which is j, then it is called as an inverse pair. Now, okay, this is called as an inverse pair. Great. Let's see what the problem says next. Given two integers n and k, return the number of different arrays consist of numbers from 1 to n. Again, I have an array which I'll have numbers from 1 to n, and I just have to tell different arrays which I could have. Again, condition is it should have only the numbers from 1 to n, such that there are exactly k inverse pairs. Again, they are asking for exactly k inverse pairs, so they will give me a k, they will give me a n. Again, n means that I have numbers from 1 to n, which means 1 2 3 4 up till n. K is I should have exactly k inverse pairs. That's it. Cool. Now, since they are saying the number of pairs can be pretty large, so please modulate with 9 plus 7. That's great. Now, for a quick glance of example, let's look at the example and see that how and what we actually mean. We mean that, okay, if my n is 3 and k is 0, so for sure we will have 3 integers 1 2 and 3, and we should not be having any inverse. So the problem itself says, okay, the answer will be a 1 2 3, and you will see that, okay, all the elements which are larger are after the smaller element. So for sure, inverse condition is larger element after him should be a smaller element. That's an inverse, but you can see there's no inverse, and that's exactly one such pair. So the answer is 1, which means that's exactly one such array giving no such inverse pairs. So answer is 1. I want to return, remember, I want to return the different arrays which give k number of inverse pairs. For example, for the next condition, k is 1. Okay, so I can simply say I want one inverse pair in the array. You can see this array has just one inverse pair, which is 3 2. This array has just one inverse pair, which is 2 1. So I have two such kind of possible arrays which I can give. Answer is 2. So far, the problem might seem, okay, what actually needs to be done, but let's look off and see that what we have to do. So ultimate aim is that we want to generate k inverse pairs. Firstly, we want to generate an array. And in that array, I want to generate k. I want to generate the array such that it has k inverse pairs. And see, generating the array, I know the array has just n numbers, 1 2 3 up till n. So generating the array, which means trying for all the possible combinations. So I will be saying, okay, I will try to generate all permutations from number 1 to n, and then I will choose the ones which will give me k inverse pairs, and that will be my answer. So firstly, similar kind of problem is this also. If you want to try it, you can try this after this problem, which is valid permutations of di sequence, because you have to generate all the permutations, and in that permutation you have to figure out what's a valid permutation. Valid is which has k inverse pairs. So you know that you can solve this also after this problem. Now coming on back, now if Aryan was saying you have to generate all the valid permutations, which means your n is a number. If you remember back in 8th class, you studied that if you have four numbers and you have to fill those locations. To fill this, I have four options. Either I can place a 1, 2, 3 or a 4. For next location, I will have three options because 1 I would have placed here. Again, I cannot place a duplicate number here. So if I have placed a 4 here, so I can only place a 1, 2 or 3. Because I know I cannot duplicate him. So for him, if I have 4 ways, for him I will have 3 ways, for him I will have 2 ways, for him I will have only 1 way to place an integer here. Okay, so total number of ways formed or required will be nothing but 4 factorial, which is nothing but n factorial. So I will have n factorial permutations for the numbers from 1 to n. But it is just we have figured out the permutations. We have to figure out the valid permutation. For us, the valid permutation is the one having inverse pair as k. So now my condition is, okay, for that one specific permutation, figure me out or give me the number of inverse pairs. If that number of inverse pairs in this permutation is equal to k, then it's a valid R permutation. Now, a normal brute force approach to figure out the permutation, or basically to figure out the inverse pair in a permutation, will be O of n square, which means for this element you are going on to all the next elements and seeing if it is after me and it is lesser than me, okay, it is an inverse pair for me. So you will go on kind of to every of these elements. So brute force approach to find out in a permutation, in one permutation, which means in one array, to figure out how many number of inverse pairs are there, it is O of n square. Simple brute force. But the standard, or basically this is a standard question also, that you have to count the number of inverse pairs itself. This can be efficiently solved in log n time, n log n time. So, and again, there are two ways. Again, we will in our 100 days 100k placement challenge, we have this problem also, in which firstly I will teach you what's a Venn victory, then I'll teach you both the approaches of finding this inverse permutations by using both Venn victory and also merge sort. But right now, just for your knowledge, I'm just telling you that to find the inverse pairs in an array of length n, your best possible technique or approach will be O of n log n. And again, there are two ways to solve it. We have Venn victory, or again, when I say Venn victory, I already mean segment tree. Venn victory is a father, segment tree is a father of Venn victory. But Venn victory I always refer because it's a very small concise code which you can actually write in an interview. In an interview, you won't be able to write a segment tree code. That's a very big. Now, coming on back, but if I still combine this n factorial into the most optimized algorithm to find the inverse pair, still I will be having a O of n factorial n log n, which is still, considering the constraints n as 1000, it is still very high. So for sure, I have to optimize it. Now, optimization is nothing for us to think of. I will simply start doing a dry run. I'll simply start doing, okay, let's start building permutation itself. So what I will do at the first place is I will start building my permutation itself. Now, to build a permutation, again, I'm manually trying to build a permutation and trying to find the answer. Now, my n was 4. Now, again, my k I have not fixed at all. K I will do and say whatsoever you want to find. K I will go and find whatsoever you want. But right now, I'm just trying to build all the permutations, because you can see my main bottleneck is n factorial, generating all the permutations. I cannot do that. That is impossible for me. So simply, just try to generate the permutations manually and see or figure out a pattern. So what I'll do, okay, for the first location, as in a simple technique I have showed above, I have 4 possible options. Either I can place a 1, I can place a 2, I can place a 3, I can place a 4. This is, okay, for the first location, I have 4 possible options. I can place 1, 2, 3 or 4. Now, if I have placed it, now I will find or try to find, if I have placed a 1 at, again, I'm saying, okay, if I have placed a 1 at the first location, what is the impact of that specific 1 considering he is at that location? So if the 1 is here, again, my impact is how many number of inverse pair he will give. He as in the 1 placed at this first location only. Again, remember, I'm only talking about the 1 right here and also 1 considering he's only at the first location. So I want to know his impact. Impact is number of valid inverse pairs he can give me, which means, okay, number of inverse pairs he can give me. And for sure, you can see if 1 is for sure fixed here, 1 is for sure fixed here, any number which is the remaining number, which is 2, 3, 4, 5, will be coming after him. So, okay, small 1 is the smallest number. 2, 3, 4, 5 is a larger number. So for sure, if it is coming after, then it is obvious. It is obvious that I cannot form any inverse pairs, because for inverse pair, larger number should have a smaller. One smaller number is a 0, but 0 is not in my array itself. So okay, there will no contribution of this specific one. This specific one will give me no contribution. Again, remember, I'm saying for this specific one, I'm not saying for this entire array, because in this entire array you can easily see, okay, 2 3 4 can be there. You can see there's no contribution for any of the elements, but yeah, 3 2 4 can also be there, where 3 2 can form an inverse pair, but I'm not talking about that. I'm only talking about the contribution of the one which I placed at this first location. Okay, great. So we saw that, okay, if the 1 is placed, then he will not give me any contribution. Again, contribution as in there is no inverse pair contributed by him. So my problem next which I have to figure out is for the remaining part. When I say remaining part, I will say, okay, one element I have taken, one element 1 is already gone. Now my remaining part is n minus 1, but my k will still remain same because I have not found any inverse pair yet. I have, because 1 will not give me any inverse pair, so for sure he will not contribute in my answer. And as I am going forward, inverse pair always go forward, so for sure nothing which is changing in the right part will impact the left part. Okay, great. Now that was the talking about 1 which we did. What about 2? Oh, if the 2 is here, he might contribute. Aryan, but how you know? Because 2 is here. Because we know, okay, 2 is at the first location, so for sure we have 3 spaces remaining. 1 can come in any of those locations, right? 1 can come for sure, 1 will come after it for sure, it will come. But if 1 will come, then for sure it's so great that if 1 will come, then I will form a pair. I will form an inverse pair. I will form, again, no matter where 1 will come, but I will be forming one inverse pair for sure. Okay, that's great. If I will be able to form one inverse pair, which means contribution of 2 will give me for sure one inverse pair. Now I'll say, okay, 2 can contribute one inverse pair. So now my problem will reduce to, okay, now you have 3 elements remaining. So remaining elements are n minus 1. And now you have formed one inverse pair. Your ultimate goal was to find k inverse pairs. You have found one. So your now new search, because you are the Thora the explorer. So now your new search will be k minus 1. Right, go and search. And the same way, if I place a 3 here, then I will be able to form 2 inverse pairs. If I able to form 2 inverse pairs, so my new search will become a k minus 2. Again, n minus 1 elements, because I have placed one, I have fixed one element, which is 3. And the same goes for this. Okay, if you placed a 4, then for sure you will have 3 inverse pairs. Then the answer is n minus 1. Again, go and try to find for n minus 1 and k minus 3. Now just one more step, just in the entire recursive tree. Now you know that you have 3 elements. And if you remember, you have placed a 1 here. Now I'm saying, okay, now you might say, okay, Aryan, now you should be remembering that you should be placed, like you will place a, like you placed a 1 earlier. So now you have remaining numbers as 2, 3, 4. So are you saying that you will place a 2, 3, 4 and try? But to know what I placed earlier, so I should be also storing here that what number I placed, let's say number I placed, because you will be passing and saying, okay, now place the next numbers 2, 3, 4. But I'll say, hold on, I just want increasing, decreasing. I don't want exact numbers, which means I want, okay, its a length is 3. I want just how many number of inverse pair are there. High value and low value will form an inverse pair. I'm not considering high value was 3, low value was 2. Nah. So if I'm saying I have 3 numbers remaining, 3 numbers I have to put, I can start considering it as a basic problem again. Okay, you have 1, 2, 3 as a new numbers, and now place them, because if you remembered, you had these numbers, right? You had these numbers. If I can just simply map these numbers as 1, 2, 3, simple. Now start off again. Let's say if I have these numbers, I can map these numbers as 1, 2, 3. Start off again, which means 1 will be 1 map to 1, 3 map to 2, 4 map to 3. So it's just for you to show that, okay, I can start my problem again. Now my problem says, okay, now you have 3. Now you have 3. Find for k number of inverse pairs. K number of inverse pairs. Again, I'll do the same thing as I did. If I did a 1, he will contribute nothing in the inverse pairs. So I'll do a k. See, if you remembered, your value was a k. So k, you subtract nothing. But then your range will decrease because it will become a k minus 2, n minus 2. And the same way, if I place a 2 here, same way he will contribute 1 inverse pair. So I'll do a k minus 1. Because k, see, again remember, k was this, because I was passing my k. Now if I place a 3, then I will have its contribution is 2, which means he will contribute 2 inverse pairs. So my answer will be k minus, like n minus 2, k minus 2. Now, but Aryan, ultimately, see, remember, you are actually building the entire permutation again and again. That's great, that's cool for us to understand, but still the complexity will be n factorial. That is a mistake which you are doing, because the complexity will not be n factorial. Why? Because if I just do a small more bit representation, then for this, when I placed a 2, you remember my problem boiled down to n minus 1 and k minus 1. Now, being the explorer, what you will do is, okay, you will have 3 elements, you will place a 1. Now he will give no contribution, so the problem will become a n minus 2 k minus 1. But Aryan, k minus 1, why? He did no contribution, right? Because see, parent value was k minus 1, so k minus 1 minus 0 I am doing. Okay, great. If I do a 2, he will give me one contribution. Okay, k minus 1 minus 1, which is k minus 2. Now if I do a 3, then he will give me 2 contribution, k minus 1 minus 2, which is k minus 3. So you can very easily see that I have a repeating subproblem, n minus 2 k minus 2, n minus 2 k minus 2, n minus 2 k minus 1, n minus 2 k minus 1. Voila! So we don't have to do all the permutations because we have a repeating subproblem, and we can memorize this. We can memorize this state. So we can just do a memoization. Now coming on back, a quick glance that what we have to do at every step. We know that we have to memorize n and k, so we will just have this as a DP state. On every of my state, I will have to go on to all the possible variations, which means I will be trying for k minus 0, k minus 1, k minus 2, k minus 3. So you will have to try for all the possible subtractions. So at a DP state of n comma k, you saw that you will have to try for k minus 0, k minus 1, k minus 2, k minus 3, and so on and so forth. So I can just simply say I can iterate my I is from 0 to actually some value, let's say k here, which is the limit which you wanted, because for sure you will not do a minus. So for sure the limit can be a k, which is the input given, which means, let's say if you wanted x number of inverse pairs, so yeah, that will be x. Here it was given as k. So this is what you will actually try doing again. So if we just see and look back, then our simple condition will look like that. Again, base case will be as usual, that if my k becomes 0, which actually I wanted, if you remember, I wanted k inverse pairs, and as soon as I find any inverse pairs, okay, one inverse pair I have found, I'm subtracting and I'm saying, okay, now the remaining number of inverse pairs which I have to find are actually this k minus 1. So I'm just simply saying, okay, if your k becomes 0, which means you have found all the inverse pair which you wanted, so simply that is a valid permutation for you, simply return a 1. And for sure, if before that, because you remember, right, you are also subtracting your n again and again. So if your n becomes 0, it's good that you have not found anything, simply return a 0. And again, there is no order for this, you can just put anything above or below. But coming on back, the actual condition, recursive case, okay, the recursive case will be simply solve, and you will pass in 2 arguments, n and k. N is the number, which is the places which you have, and k is nothing but, okay, you have to find k inverse pairs. As I showed you, for every state I will have to go on to all the i's where I is from 0 to k. So for sure we will try on for k minus 1, k minus 2, k minus, again you will try. What are you doing? If you are saying that you place an element, there is chances that he doesn't form pair with anyone. He form pair with 1, he form pair with 2, he form pair with 3. Now if I am saying I have n elements, so at max he can form pair with n minus 1 elements. So for sure you have to put a limit also, that anyone can form maximum pair. Okay, what is allowed to him, that how many pairs he is allowed to make versus how many pairs at max he can make, which is n minus 1. So I will put a minimum cap, okay, minimum of k and n minus 1. Now k represents that how many I am asking him to make, and n minus 1 is that how many possible he can actually make. So whatsoever is minimum, take that, because ultimately that number of pairs he will be actually making in the real life. So I will simply say that simply go and solve, like again you took one specific element, so reduce your n by 1 and your k will be reduced by the specific value, which is k minus I, as we saw above in the diagram also. That is exact same code. So as you saw, I initialized my mod, simple global variable. I initialized my DP as a vector of vectors, a 2D vector, because I want to have it as a nk, right? I put it as global. You can also put it as a local and then pass as an argument. That's up to your choice. But to make the code much more cleaner, I usually initialize global variables. Now I initialize this with saying n plus 1 k plus 1 word, but Aryan, why n plus 1 k plus 1? Because simply you can see that I am checking for n and k, so I need to have an indexing of n, like I need to have this index n and k, so I have to initialize with n plus 1 k plus 1, and by default value for dp mostly it is -1. I'll go and simply solve for n comma k. The recursive call simply look like the simple base case: if k is 0, return 1; if n is 0, return a 0. As simple as that. Now a simple memoization step, the same way a simple memoization step, that is exactly same of the simple DPs. The simple recursive case will look like that. You have to give me the count of the arrays, right? So I'll initialize the variable called as count, and he will go and simply keep on adding that. Okay, solve for n minus 1 k minus I, where I goes from minimum of like k n minus 1, whatever is minimum, just have that I. And that's how, again, do mod at every step whatsoever you want, and with this you can actually get your answer. But if you see and look back, the complexity will be O of n into k for the DP state you have, for the DP state you have, and for every state you will actually be iterating on the entire loop from 0 to minimum of your k and n minus 1. So it is minimum of n and k. That is your time complexity. Space is for sure the DP state which you have initialized. You will see it is n and k. Firstly, if you will see that your n was 1e3, your k was also 1e3. Considering these constraints, this should not have worked. Considering these constraints, DP should not have worked, but lucky you, it will work. It is the issue with the test cases of Leetcode. It is working. It should not have ideally worked, but it is working. Okay, no worries. But still, now you might ask, we want to improvise it. Yeah, we can and we should. But before that, again, when improvisation comes in picture, we try to always think in the bottom-up approach. Again, we can improvise the top-down approach also, which is this one, which we write here, because we know for sure this time right now it will actually be 1e9, which will for sure not work. But right now it is actually, if you just copy this code, now copy this entire code and try to submit, it will submit. But that is not ideal test case scenario. So for sure the test cases are not pretty good in Leetcode. But for sure now you want to improvise it. Now whenever I talk about improvisation, I usually talk about saying that convert to a bottom up, and whenever I say improvisation, I usually mean a space optimization. But still we need the time optimization also. For that, we can easily see that the optimization which we can have in time will be in this specific state. But it might not be readily visible to you. So let's first convert. Again, I am saying the time optimization can be done both in top down and the bottom approach. But for a quick glance or for an easy glance for you, I will convert this exact same top down code to a bottom up code very quickly. How? I'll simply go and look at the top down code which I wrote. I will simply replicate that code. Okay, I will simply replicate and say the initialization I will simply have, okay, because our initialization are usually by 0. So I'll just initialize by 0 in the bottom up. That's the one change which I did. Then I know I have to go on to all of my n and k. I'll go on to all of my n and k. That is one thing I done. I know, okay, I had my base case when my k is 0, I should return a 1. So okay, my base case when my k is 0, I should put a 1, and that thing I should return. Okay, great. Then my actual recursive cases, okay, when I have to iterate on all the numbers from 0 to k minus n, k or n minus 1 minimum. Okay, iterate on the entire thing from 0 to k comma n minus 1 plus, and then simply exact same condition, because instead of count you have this variable called as dp of n comma k. Just simply add this specific value, which is n minus 1 k minus I, n minus 1 k minus I. And with this copy pasting of the top down code to bottom up code, my entire code is converted. I can simply return my dp of n comma k. Just one thing, make sure that okay, I have to actually replicate this entire code, that okay, it should look much more familiar. I converted these to big N and big K inputs, so that you can actually visualize that you are actually solving for n comma k at every step. Now, okay, in very quick glance, we have converted our top down code to bottom up code. So, but again, it is just conversion. Copy. We just did a copy. Exact same code, we just copied. But time complexity is just time and space, both are still same, exact same, because we just did simply a copy. So what can we do now? So can we see one thing? We can just see for sure one thing, that we will have to go on to n and k. It's a primary DP state. It's a prime DP state for us. If you remember and go back, it's a prime DP state for us. We will have to go on to it. Maybe we can, maybe, I'm not sure. Maybe I'll just try now. Maybe we can actually improvise this specific, and I would not have to add an extra of this factor. Maybe again there are multiple other optimization also that maybe you can just, again for sure you will have to try for all the n, so that is one thing you can never optimize. Maybe other thing which if this thing would not work, I would have gone on to and try to optimize and remove k itself in the DP state. That is the next step. If this would not work for me, then I would go and try to remove the k. This would have been my next step, because I know I can never remove my n. This is how you actually start thinking how to improvise. Now if I want to actually remove this entire thing, so I have to go and get to know what this entire thing is actually doing, then only I can actually remove it. So just to show you a glance of what this loop is doing, I'll just walk you through that, okay, what the entire thing is doing. Now if I just go and see and check back this entire stuff, this when the k is 0, it just simply says, okay, when the k is 0, simply put the values as 1. So this portion is simply putting the values as 1 no matter what. Okay, great. But what is this specific thing doing? Now for that we will not go into very much, okay, I'll try run every step. Nah, you don't have that much time, neither in a contest nor while understanding. So for that, the best part is you just pick any point. I pick again it, and see, it can be a false positive. So always, let's say if I pick one point, so I will also parallel try for some other point also, so as to make sure, okay, I am on the same grounds. Now if I pick one point, I just pick my n comma k as like this. Okay, my n comma k is the specific value 4 and 2. So my k is 2, my n is 4. This is my, so I am saying dp of 4 comma 2. I'll try to find the answer. So my existing code, what he is doing is he will go and check for dp of n minus 1 k minus I. Now to find the I, I'll go and say, okay, I will be minimum of k and n minus 1. N is 4, so n minus 1 will be a 3. K is 2, so k will be 2. So minimum of them will be actually a 2. So I can go to a 2. So I can go from I is 0, I is 1, I is 2. I can go to these three states. So I'll go on to n minus 1. N minus 1 will be this. I'll do a k minus 0, k minus 1, k minus 2. So it is nothing but my green cell is a summation of dp of these three upper white cells. That is what I am saying it is. Now let's take in the loop what will happen is, okay, my n will still remain same. Now I was at this specific column. Next time I will be at the next column. Okay, I'll be at the next column. So I should go and try to find the column value of this, sorry, the cell value of this specific cell, because by the loop conditions I will go and try to find this value next, right? Okay, great. So I'll go and try to find this specific value, which is n comma k. Okay, great. So for this n comma k, I can simply see that my n is nothing but my 4, and because n is 4 and k is 3, and k is 3. So k will be a 3, n minus 1 will be also a 3. So my I will actually be a 3. So I can simply say that I can go from 0, I can go from 1, I can go from 2, I can go from 3. So this for to find the answer for n comma k, my earlier loop, what he could be doing was he will be going to dp of n minus 1 k minus 0, k minus 1, k minus 2 and k minus 3, and he needs the summation of that. So if I look back both of these parallelly, so you can easily see that I simply did one thing. I know this was already pre-computed in this specific cell n comma k. Again, if it is not visible, just zoom it up. I know that this entire thing was pre-computed and stored in this cell n comma k, right? So, and I know that I had already computed this specific portion which contains this specific sum. So why I am repeating my effort? I should rather do, I will get this cell which is just n comma k minus 1, which is just beside cell to me, and the above cell which is the new cell added, and then I can simply add them, and this will give me n comma k. So I don't have to go into the entire loop. Okay, that makes sense. That what we can do is, okay, my dp of n comma k, which is this specific cell, I can ask him and say he can be my dp of n minus 1 comma k, which is this previous cell, and I'll also add a dp of n minus 1 comma k. This is n minus, sorry, I just greeted. This last cell is n comma k minus 1, last cell, and the above cell which is just above me, it is nothing but dp of n minus 1 comma k. Okay, this makes sense, Aryan, but are you sure this is true? Yeah, seems like with the pattern, but I'm not sure. Okay, no worries. Whenever you're not sure, because it is just that you saw a pattern in just one example, but you have to figure out that pattern in actually bigger example. So let's take some other values. Okay, now take again the code still remain. Okay, this is my previous code which I'm trying to see what he is doing, and in that I'm trying to figure out a pattern that I can utilize that pattern, because right now I saw, okay, I just need to, for the current cell, I just need my previous cell and my top cell. That is it, and I will find my answer. But to just verify, let's please confirm that with some other cell also. So I'll take this specific cell and I just say, okay, my this specific value n is 3, k is 2. Okay, my n, again I'll just simply erase this and I'll say my n is 3, my k is 2. N is 3, k is 2. So my k is 2, n will be 2. So my I will go on up till 2. From 0, 1, 2. So I'll just say k minus 0, k minus 1 and k minus 2. So for this cell n comma k, my answer will be summation of these cells above. Again, their corresponding dp values. Okay, great. That is super great. Let's shift because you know that rk is going right. I am at the same row, but next time I'll go on to my next column. So I'll be finding the answer for this specific column which I showed you earlier also. When he will be found, then what will happen? He will simply go and try. Okay, I am currently 3 and 3. My n is 3, my k is 3. Okay, now let's see what is happening. My n is 3 and my k is 3. N is 3, k is 3. So k is 3 and my n will be n minus 1 will be 2. So minimum will be still be a 2. Okay, still be a 2. So I can try for I equal to 0, I equal to 1 and I equal to 2. This is the values which I can try. Right. Okay, which means I'll say k minus 0, k minus 1, k minus 2. Oh, okay. Did you see one thing? Now this specific cell n comma k is the summation of these cells. Is the summation of these cells, but my previous cell is the summation of these cells. So the answer, if I just call about the answer for this new cell which I got at, it is the summation of these cells. Don't you think it's a window which got slided down? Like earlier the window was like this, but then the window slided and it became like this. Oh yeah, it seems like. But Aryan, why it was not the case for the previous thing? We will see that. But yeah, right now we saw, okay, earlier I was doing, okay, simply adding this for this cell, for this pink cell, I was adding green cell and my above cell, let's say is a blue cell. I was adding my green cell and blue cell, but then I realized, it's kind of a sliding window, so I would have to subtract this cell also. How a sliding window works? Oh, that makes sense. So basically, I have to subtract this cell also. So what I have figured out right now is, earlier I only knew one knowledge, that for my pink cell, which means the new cell which I got, which is dp of n comma k, I would be just getting the previous cell, which is nothing but dp of n comma k minus 1, and which is same as this specific value, which is the previous cell which I had, and the above cell, which is dp of n minus 1 comma k. But then I also realized that I need to subtract this value. But Aryan, how would in the life you would know this value? Like in which cell you have to subtract? Because you remember, right, which cell you have to subtract. So we could realize that how actually and why actually we needed to subtract the cell right here, but in this case we never needed to subtract the cell. Why is that the case? It is, and this example will actually help you to know what we have to subtract. So if we can see and realize, okay, if I was at this specific cell, I'll take the minimum. Now minimum of these two values. So for sure, k and n minus 1. So, and again, I'm just doing, okay, I'll just do a subtraction from my k minus something, k minus something, so on and so forth. So I am saying that I will have, at max, I'll subtract a k minus n. That's the maximum I can actually subtract. But for that subtraction, my k should be greater than or equal to n. Oh, so I'm saying my k minus n should be greater than or equal to 0. So that only it will actually work. That makes sense. That if again, this is my current values of dp of n comma k, but then I realized I might have to subtract something. Now what I just want a relation that between k and n, I just want a relation such that it is equal. Whenever it is more than 0, I can actually try subtracting, else I will not. So I got to know, okay, k should be greater than or equal to n. only then I can actually subtract from my k, because you remembered I'm subtracting, you remembered I'm subtracting from my k, I'm subtracting the specific value I. Now I'm saying I'll subtract only when this k minus n, so basically this I value k minus n should actually be greater than or equal to 0. Only then I should actually subtract, else this value will become negative, which I never want. Okay, but still that is kind of unsure that how it will work, because here you will see that your n was a 3, so your n was a 3, you will subtract, okay, your k was actually this specific 3, so you know that, okay, you will try for 3 minus 3 will be a 0, so you remembered, okay, you will subtract this value, which is this specific value. For him, for this value you will subtract n minus this specific cell, which is dp of n minus 1, which is 2 and 0, specify cell 0, you will subtract this cell. That's okay, but maybe, but why was that not needed here? Because you will see that here, if I go back and ask him, it is nothing but for him this this k minus n will be pointing here, which for sure will be not positive, not greater than 0. So for him, n minus k was not greater than equal to 0, so it was never possible for him to subtract out anything, because the window itself was starting from this specific portion. Okay, so we got to know that we will just have a subtraction of top value similar to a sliding window. We will simply slide down that window, and we got to know that we will subtract that specific cell. Again, if you want, you can just formulate that too, that how your actually k and n are moving, depending upon that you have to subtract it. But coming on back, we have to go and let us say that if we figure out my dp of n and k by simply adding previous cell and top cell, but then I have to also subtract the contribution of the previous cell to me. I have to subtract its contribution, which is the first cell for him, which is nothing but this dp of n minus 1 comma k minus n. Again, you can just write down in the pen and paper, like draw this matrix and put all these three matrices, like 1 2 3 4, all these 4 matrices together, and for the specific values, and then try to dry run also to parallelly make sure that you are with me. Now, so far we have just seen that we can remove this entire loop and convert it to two conditions. One is that for this current cell, I'll go on to my previous cell and my top cell, I'll add that, but I know that it's kind of a sliding window approach, so I will just have a quick check. If my k is more than equal to n, then I can subtract my n minus 1 k minus 1 cell also from my current dp, which I got from above. But still, whenever you do a subtraction in a mod, you have to also add a plus mod, because see, a minus b, when you do a mod with m, it can be, it is not always true, so you have to do a minus b plus m mod m plus m mod m. That's simple mod operation which you have to perform. Okay, that's a mod operation which we have to do. That's simply a mod issue which we are facing, but no worries whatsoever. We have got dp of n comma k. So are we saying that we just have to remove these lines and put these lines, and that's it for our answer? That is what I was thinking. And this is the issue which actually took me 1 hour to figure out what I was doing wrong. So I just simply modified my code like this to this, and I thought it should actually work, but it started failing, giving wrong answers. Then I was confused. Why? I did everything right, everything seems correct, everything seems okay. Why? What is wrong in this? So if you take a very small, again, whenever things are wrong, go to a very small example. If I take a very small example, when my n is 1, k is 1, again, it's a valid example because my n and k both start from 1. So it's a valid example. So with this current case, which was actually working for me, for sure, I never went on and say about 0, because n is 0 is not a valid case for me. So I never went on there, neither in top down nor in bottom up. So when I initialized my array, it was by default a 0. It was by default a 0, and that is completely okay. That is completely okay for me, and it's a by default thing which is actually a 0. But if you go back and check that when your k is 0, you saw that it will always populate to a 1. So this value is populated because of this specific code. Now, when he went on to this specific line for this cell, which is n1 and k1, yeah, n1 and k1, dp of 1 comma 1, dp of 1 comma 1, he will say and ask, okay, add a n minus 1 k minus I values, and you will see all the values are 0. So for sure he will add and simply give me a 0. Okay, that is great. So you will see that I am simply getting a 0 considering my old code, but the new modified code which I will write, what I will get. Okay, same value he will populate as 111. Again, I did not touch it because my initialization of dp was a 0 with a 0, so he never touched this above line, he never touched this. But because of this code, the first column will actually become a 1 only after n equal to 1, because you can see n equal to 1 I'm starting off with this specific piece of code. My dp of n comma k, let's see, let's dry run. My dp of n comma k will actually be my previous cell, my top cell, my top cell is a 0, my previous cell is a 1, so he will give me a 1. Okay, great. Then the next piece of code, because you know that k is 1, n is 1, both are 1 1, so it is for sure equal. So he will come down in here. If he will come down, dp of n comma k will become a dp of, again he have to just subtract this value, which actually is he's considering can be a sliding window for him. So he will be going and subtracting our dp of n minus 1 k minus n. So he will be subtracting n minus 1, which is n is 0, k minus n is actually this specific cell, which is 0. So he will subtract on the cell which is already a 0. So he will subtracting a 0 here. So you will get answer 1. So you will putting answer 1, which is actually wrong because you should be putting answer 0. So as I was saying that you try to take a sliding window approach, but that is valid afterwards. For the first cell, you will be trying to access the top cell above him, which you never touched, and he will try to access the sliding window concept, same sliding window concept he will try to access, but then he will not work. So simply you just want to do one thing, that put a 1 here, so that whenever he is trying to check this window, he should be able to get that specific value. So please initialize your dp of 0, 0 with a 1. So the only change we have to make sure, again this point stuck me for around half an hour. I was so stuck. What's the issue I'm doing? I was just thinking, I was not dry running. As soon as I dry runned, I figured out that what is the issue. So whenever in future you are actually stuck and you think the approach is correct, please have a try run between the approach, brute force approach which you took and the optimized approach which you are taking. Have a dry run. Then you will figure out the optimization which you did might actually impact the edge case. Edge case was the first line. For him, the above line was never initialized. So for him, the above line was a default line, which will not follow the sliding window concept. So as to make the above line follow the sliding window concept also, I just have to place a 1 here so that it is subtracted and it should actually follow the window logic. Okay, now with this only change, my answer will actually be correct. Okay, now let's have a quick glance at the code. The code is exactly same. I just have this initialization of my dp of 0, 0 and the change which we have to do. With this, we saw that we have removed the extra loop which was taking, and now the time complexity is O of n into k and spaces O of n into k. Now we have converted to bottom up, and that was great. We have optimized the time. Again, this specific thing you can actually also apply in top down approach also. Exact same thing. From the rather than the loop itself, remove the loop and put these two conditions. That will also be good for you. But can we still optimize it much further? Yeah, maybe we cannot, because one thing we have seen that the best part about converting in bottom up approach is that we can actually see how things are looking like. So what I can simply do is I look at my previous code, which is the existing optimized bottom up code. I will see that for my dp of n comma k, I'm only accessing dp of n and dp of n minus 1, which means for my n state, I'm only trying to access n minus 1. That's it. Rest of the states are never used are never used. So this is the standard dp optimization, space optimization technique which you have seen so far, is that rather than initializing a dp with a 2D dp, I know I need my dp, I'll need my this dp and this previous dp. This previous dp I need. This previous dp I need. This previous dp, and this is a dp, this is a dp, this is a previous dp, this is a previous dp. So I know I need my dp and previous dp of size k plus 1. That's it. So the only modification is I will replace this dp with the dp, this dp of n minus 1. I'll replace this with the previous dp, it is a dp, it will be a dp, it will be a previous dp, and this is the only change which I will do. Let's see how. So rather than my the 2D vector dp, I have two DPs, which are DP and my previous DP. So DP will be nothing but simple of size k, both of them. The only change which I did was wherever I had DP, wherever I have DP, I will have a DP and a previous DP. Sorry, wherever I have DP, I will have a DP, and wherever I will have a DP of Amazon, I will have a previous DP. So you will see that here I just initialized my, again you will say, Aryan, but you were saying that wherever you have DP, then you will have a DP here, then why are you, and wherever you have a DP of M-1, you have previous DP here. But remember that this is just the initialization which will be used right here, which will be used right here for used right here for your DP of N-1. So this is nothing but a previous DP contribution. So I'll say previous DP of 0 is actually a 1, and here I just took both of them because no matter what, it will, the first k equal to 0 will always remain a 1 for sure, ever. And the only change is here I changed DP, it's a previous DP, it's a DP, it's a DP, it's a DP, it's a previous DP. That's it. This is the only change which I did. And thus please make sure that you assign, because it's a row, right? N-1. N-1 is the previous DP, N is a DP. Now for the next loop, okay, previous DP should be assigned DP, and DP you will calculate now. So I'll simply assign my previous DP to a DP, and this I'll simply return my DP of k, because I was earlier returning my DP of n comma k. And this is the only change you have to do. With this, you can optimize your space from n into k to just O of k to 2, which is nothing but O of k itself. And that's how you can simply solve it. I hope this got you. See you. Goodbye. Take care. Bye-bye. It was a very long video. It took a lot of time because of that optimization. But yeah, cool. No worries. Bye-bye.